Hi and welcome. I'm trying to learn biology, today homeostasis, and in the second part of the video we're gonna do shoulder impingement training. And if you participate in the shoulder impingement training, that is at your own risk. Homeostasis. Homeostasis. Principles. It is vital that the internal environment of the body is kept constant. This is called homeostasis. Okay, that means that the internal environment, so what happens in the body, is constant. That means that the body does not go 100 degrees hotter and colder very fastly. Now, how we can remember it? I would say we take the word homeostasis. Homo means human, and stasis we're going to say that means static. So the homeostasis makes that the human is static. So that all the internal environment inside of a human is static and fixed, firm and constant. The different factors in the body that need to be kept constant include the water content, the temperature, the sugar content, and the mineral or iron content. Iron is written in brackets. Does that mean that iron is the same as mineral? Or that ions are minerals? Okay, what the things have to be done by the homeostasis to keep the internal things of a human static? The water content. So that means there should not be suddenly too much water or too little water in the human body. Also the temperature should be stable, and sugar content. Not too much or too little sugar jumps fast, and also the mineral content or the iron content. Water, temperature, sugar, and mineral. This is in a way already enough. Many of the mechanisms that are used for homeostasis involve hormones. Hormones are chemical messengers that are carried in the bloodstream. So inside of the veins of a human body, there are these, or inside the blood vessels, there are the hormones. And they are chemical messengers. Whatever, they are going through the bloodstream to another places in the human body, and then they are making the things happen so that the water content, the temperature, the sugar content, or the mineral content, all together under homeostasis, are stable. And these hormones are released by glands and passed to their target organ. That is not the first lesson, I think, of this book. Now, somewhere in the human body are glands, and we have informed that these glands are transported through the blood vessels to the organ to which we should come. And hormones take longer to have an effect. Okay, we're not explaining it longer. Okay, and these hormones seem to do something when that this organ does something, that the temperature, the water content, the sugar content, or the iron content is stable. Hormones take longer to have an effect compared to nerve impulses, but the responses usually last longer. Okay, nerve impulses. That means if what is it called? Whatever. If we're hurting ourselves, we feel it immediately. And hormones take longer. If we want to get warmer or the sugar content is too low, that doesn't work instantly. That makes sense. Not in the whole body. The water content can change just in an instant. So, okay, nerve impulses are immediately. We feel pain immediately as soon as this happens, more or less. But the water content of the human body does not just change in a second. It's logical. And they're also going through the bloodstream, so they're slow. Okay, these glands, wherever they are, they are sending out hormones. These hormones are going through the bloodstreams, through all the veins. And then they are one day coming to an organ. And that organ now regulates the temperature, and the water content, and the sugar content, and the mineral content. Now we could go, for example, to the heart and tell the heart to beat faster, and if the heart beats faster, I don't know what happens. The body actually cools, I think. Whatever, they are going to the organs and they are doing this stuff. But they last longer. The hormones last longer. So a nerve impulse, like feeling something or getting pain, lasts only for a few seconds or shorter, but if hormones are released, they can have an hours or days longer an effect. The homeostasis control mechanism in the body work by negative feedback. Hopefully we get it explained. This means that receptors in the body detect a change in the body. These changes are then processed in the body. Then effectors bring about a response that reverses the change so that the normal level is restored. This is much like many artificial control systems, such as the temperature control in the house. So we're not controlling, make it 25 degrees, make it 25 degrees, make it 25 degrees. We are going, we're getting 24 degrees, make it 25. And then we're just resting again. And only if something works bad, we're going and fixing it. If I understand it now correctly. Okay, now we're having a little circle here. Receptors, like a thermostat in a room, detect a change. A processor compares the stimulus with a set point, like the temperature on the thermostat dial. An effector produces a response to correct any difference between the new level and the set point, like a radiator being turned up. And that goes on. Okay, we're going to come to the back. That is too much, and that is a separate subject in a way. We're concentrating now on what homeostasis is. We're going to come then back to the next thing, and that will be then part or whatever. Now, what did we had about homeostasis? First, homeostasis is to keep the human, static, with the water level, the temperature, and the sugar content, and the mineral and iron content. And that is done through hormones. And these hormones, that is whatever, something, sent out by glands. They are somewhere in the human body. And they are traveling through the bloodstream. And they're going then to a target organ. And at that organ, they're doing something that these four things are regulated. The sugar content, the water content, the temperature, and the mineral content. And that is it. The rest is something else. First, homeostasis. And that is homeostasis very short. And I think that's very good what we have here. What I just said. That means we're having enough for a little presentation. We're going to go in the next part, and where we will make a little presentation and saying a very short, that's even the title of the video, of a presentation, a very broad description, what is homeostasis. And then we're going to say what I just said, and then other people can watch that also. And then we're going on and looking for what is else written here. These are 4 pages dedicated for homeostasis, but we are going to do our business. So in the next video, we're going to go and try to make a video about homeostasis very broadly. What is it? So if you're just here for that, for homeostasis, you can go directly to the next video. We will do now the short impingement training. If you participate in the short impingement training, that is at your own risk. We're doing a few shorter circuits. We're going back, up, and front, and down. And again back, up, and front, and down. And now backwards and front, up, back, and down. Again in front, up, back, and down. Now we're doing the crab in the morning. The legs are standing around shoulders wide apart. We're breathing in and lift the arms up. And breathe out and lean back and out the chest to the sky. Breathing in lift the shoulders up. Lift the arms up and out again down with the arms and out the chest to the sky. Again in and down. Next exercise. Legs are standing wide apart. We're going a bit into the knees. Bending forward with a straight back. Letting the arms hang. And now we're pinching the scapulas together and do it with effort. Now make fists, lift the arms up and pinch the scapulas together. Release the arms and the scapulas. And the second round. Pinch the scapulas together. Again with effort. Now make fists, lift the arms up and still pinch the scapulas together. Lift the arms down and the scapulas. Next exercise. Into the knees, hinge forward with a round back, let the arms hang, make fists, turn the arms to the inside, lift the arms high up and bring them together. Straight slowly up and bring the shoulders down and together. So arms high up and together, shoulders down together. And release. And we're doing it a second time. Into the knees, hinge forward, with a round back, let the arms hang, make fists, turn the arms to the inside, lift the arms high up and bring them together. Straight and slowly up, bring the shoulders down and together. Arms high up, hand together, Shoulders down, to go. And release. And the next exercise, we are doing the shrug. We are lifting the arms up. And now shrug the shoulders up. Lift them down again. If this exercise causes pain, then don't do it. Again, the arms up, or the other one. If it causes pain, then don't do it. Lift the arms up. And lift the arms down. Breathe again in, lift the arms up. The last time, shrug the shoulders up. And release again. The next exercise, the pretzel curl. Arms together. Bring them down to the outside. And again, down to the inside. And the last time. And now we're doing the sun dive. I'm using a tennis sock, but you can also use something else. We're letting it with a straight arm away from us, down falling down, and we're trying to catch it again. And now with the other arm. And we're doing just stretching. Bring one arm in front, shoulders back and down. Pull the arm in, have flat fingers. Try to relax the arm and go a bit back with the shoulder. And the other arm in. Shoulder is back and down. Pull the arm in, have flat fingers. Try to relax the arm and go a bit back with the shoulder. And that was the short control training. I thank you very much and until next time.